The reduction of CFCs into the atmosphere through the Montreal Protocol was an important success in preventing damaging effects to the ozone layer. Because of the protocol, stratospheric chlorine levels have declined and stratospheric ozone levels are projected to return to pre-1980 levels in the next few decades. But recent observations show another gas not regulated by the Montreal Protocol rapidly increasing in the atmosphere, which could have a very damaging effect on the ozone layer. Methylene chloride is a colorless volatile compound that can easily dissolve with many organic compounds. It is a common solvent widely used in paint strippers, degreasers, and in the pharmaceutical industry. It also is used to create the non-ozone depleting chemicals called hydrofluorocarbons, which are now being produced to replace CFCs. In the 1970s, it was discovered that chlorine and bromine released from anthropogenic compounds like chlorofluorocarbons and halogens could destroy ozone in the stratosphere. Industrial emissions of these halocarbons have led to widespread depletion of Earth's ozone layer in recent decades, including the Antarctic ozone hole phenomenon. While ozone depletion today remains a persistent environmental issue, there are signs that ozone recovery is underway because of steps taken from the Montreal Protocol. Unlike CFCs, which have long atmospheric lifetimes, methylene chloride has a very short lifetime. But long-term measurements of methylene chloride have shown that its tropospheric abundance has increased rapidly in recent years. Between 2000 and 2012, surface concentrations of methylene chloride increased almost 8% on average per year. Since natural emissions of methylene chloride are small, this recent growth is likely from industrial sources. Research published in Nature Communications shows historic methylene chloride levels and tries to model future trends of the compound in the atmosphere. Figure 1A and B shows the large increase in methylene chloride since 2013, increasing mainly in the northern hemisphere. Figure C and D model future trends of methylene chloride based on the recent average growth rate, which is estimated to be between 2.8 and 6.1 parts per trillion per year. This linear rise in methylene chloride could have devastating effects on the ozone layer's ability to recover from the damage historically caused by CFCs over the course of the 21st century. How does methylene chloride affect stratospheric chlorine? Because it has a short stratospheric lifetime, around 1 to 2 years, methylene chloride disassociates rapidly and largely adds to the chlorine levels in the lower stratosphere. Methylene chloride accounts for about 10% of stratospheric chlorine, but this could significantly increase over the 21st century if methylene chloride growth continues. By 2050, methylene chloride is projected to account for 20 to 30% of total chlorine production in the lower stratosphere. This model uses a peak on chlorine levels in 2049 to show how long it would take to recover. How does methylene chloride affect stratospheric ozone? Ozone is most sensitive to methylene chloride in polar regions. By the time air reaches high altitudes, all chlorine that entered the stratosphere as methylene chloride has been converted to chlorine. The largest ozone decreases from methylene chloride are in the southern hemisphere, where the Antarctic ozone hole forms each spring. Figure 4 shows simulated ozone changes due to methylene chloride in the recent past and future period. Ozone loss due to further methylene chloride growth is projected to increase significantly in coming decades. Methylene chloride is predicted to have a dramatic effect in ozone formation. The Montreal Protocol has been very successful in alleviating polar ozone loss. It has been estimated the Antarctic ozone hole would have been 40% larger by 2013 had the protocol not come into effect. Figure 6 shows the model estimate of Antarctic chlorine and column ozone evolution with and without methylene chloride. Antarctic column ozone returns to pre-1980 levels in 2065 when methylene chloride is not considered. The inclusion of methylene chloride delays the ozone return by about 30 years. The work being done by scientists all over the world to understand the effects of methylene chloride on ozone and to predict how the ozone layer will react is very important for the long-term health of the stratospheric ozone layer.